Welcome to the next lecture on data formats. In today's lecture, I'll talk about relational data format, specifically CSV, and its more recent standardization effort, CSV on the web. But before I get to describing CSVs, I need to remind you of the relational data model, which you may be more familiar with from your databases course. So when we talk about a relational data model, we talk about tables, columns, rows, tables having names, and columns from one table referencing records or rows from another table. For instance, here we have two tables or relations concerning airports. In table A, we have two rows. On the first row, we have the Prague airport, and we say that in January there was, let's say, 20 centimeters of snow, and the second row in Dubai, in January there was no snow. So that's our relation A, where we have three columns, two rows. And relation B says that an airport is located in a continent, and here Prague is in Europe, Dubai is in Asia. And again, the data is shaped into columns and rows. Now, when we talk about a relational data model, then each table should have a so-called primary key defined, which is a set of columns which contain unique values, which uniquely identify a row within that table. So in our case, the airport ID is a primary key in both relations. And when a value from one column in one table references a record in a second table, that's called a foreign key. When we want to describe how the data looks like in those tables, we create a schema. And for the relational data model, we have a relational schema, which basically describes the relations of the tables. So it describes which columns which tables have and what data types do the values in the columns have. So in this case, airport and month are strings, and snow is a number. And regarding the table B, airport is a string and continent is also a string. Then relational schema contains the definition of the primary key, in which in our case it's the airport column in both cases. And also the relational schema contains the integrity constraints, such as the foreign key definition, which says that the airport column in table A references the airport column in table B. And this is it. This is what we talk about when we talk about relational schema, and you know this from your typical relational databases where you query the data using SQL. And this brings us to our first relational data format. The use case here is that you have your data in your relational database and you want to share the data with someone else, or you want to create a backup of the database. So what you can do is, if you want to stick to relational databases, you can export your data in a form of a SQL dump. A SQL dump is a script in the SQL language, which when you run it in your relational database, it creates the database, it creates the tables, it creates the integrity constraints, and then it fills those tables with the data that you had in there. So in the slide, you can see an example of such a SQL dump. And this works for when we stay in relational databases. However, what if we want to work with relational data in other tools? Then the SQL script or SQL dump is quite useless, because no other tool than a relational database is able to get the data out of a serialization like this. Nevertheless, for some use cases, this is a valid serialization. Right. So before I get to CSV, which is today the standard for representation of relational data on the web, I will take a history detour and talk a little bit about what the data formats for relational data looked like before CSV was, well, standardized, maybe a strong word, but before someone written up a specification that talks about CSV and others can follow that specification. So the first approach was called Delimiter-Separated Values. There is a acronym for that, DSV. You might have come across this one sometimes. And this is a most generic data format. It talks about delimiter. However, it is not specified what the delimiter is. It just says that there is a delimiter that separates values. This format comes from the Unix world, where Unix is a system heavily dependent on working with texts, and therefore when you want in such a system represent data, this DSV, well, I would not call it a format, but approach, the DSV approach, is certainly valid. There is one fun fact here, and that is that the label actually does not make any sense, because it should correctly say separated values. And this is where we take another detour. This time it's a terminology detour, and we'll talk about delimiter, which basically establishes boundaries of, for instance, some value. So it delimits the start and the end of the value. So for instance, an XML tag, the start tag and the end tag, those are delimiters. Or if you surround a value in double quotes, that is also a delimiter. But this is not what DSV is about. DSV is about separators, because it says, and that's the second example, separator separates two things. So it doesn't have a start and an end. It just says when there are two things, we separate them using this separator, in this case a comma. And those two actually can be combined, so you may have a delimited and separated values. For instance, each value is delimited by double quote, and those values are separated by a comma. So yeah, this is just that the DSV, even though it is used, the label does not make sense in a strict technical or from a strict technical point of view. Now, an example of such an approach can be, for instance, this list of Czech company IDs. So this is a data set that is live. You can find it on that URL that you see in the slide. And there is a screenshot of the description of the data format. So it says this file is in the UNL format, which, by the way, doesn't exist. And it uses a pipe symbol as a separator. And it is encoded in ISO Latin 2, so it is, again, a bit harder to work with. And how such a file looks like inside, you can see in the slide. So it is actually a value, then a pipe, then another value, a pipe, another value, a pipe, and so on. So this is not the way relational data should look like. And this format probably comes from the unload statement of a concrete implementation of a relational database, IBM Infomix, which talks about how you can dump your relational data, and this format is described there. So UNL may stand for unload your database. Another a bit more standardized approach is type-separated values. Here, as the label suggests, the individual values are separated by tabulators. This format actually has its own media type registered with IANA, and Here, rows are separated by new lines, fields are separated by tabs. There can be no tabs in values. There is always a header, which means that on the first row there are names of the columns, and then there is data from row 2 on. And there is always a constant number of tabs per line. So it is quite straightforward, quite easy to work with, and it is also quite old. It doesn't say how old it is exactly in the media type specification or registration, but since the contact information is, as you can see in the rectangle, uses Gopher, I guess this one is pretty ancient from the point of view of today's web. Yeah, so at that time, when you found data on the web somewhere, or data on a CD or on a diskette or something like this, you would first have to take a look inside and decode what format does it use, and those formats would be very different. So in 2005, someone decided that enough is enough, and we need a specification for a CSV file, because CSV files were used even before, but I don't even mention them here because even though in the title it says comma separated values, again inside it was very different, and I will show you some examples in a moment. However, from 2005, we have this RFC 4180, which is not an internet standard. However, it is the only specification we can refer to at that time, and it actually sounds quite reasonable because it says, well, actually, right away, the first thing it says about encoding does not make sense on the web, but that was changed. Because at the time it says the default encoding is US ASCII. If you use another encoding, you need to specify it in your HTTP content type header. This was later changed to UTF-8. So now the default encoding, which makes sense on the web, is UTF-8. And if you use something different, which is not recommended, you should specify it in your HTTP content type header. Anyway. Except for the encoding, the rest of the specification is quite clear and quite straightforward. Individual lines in a CSV file are separated using CRLF, carriage return line feed. The individual columns are separated by a comma, of course, comma separated values, right? If a value contains either a line ending or a column separator, it needs to be escaped, and the escape character is a double quote. So values which contain the dangerous characters, line endings and column separators, they are surrounded or delimited by a double quote, and if the value itself contains a double quote, the double quote is doubled. And the header on the first row is optional. Now we have the two examples. The first one is a typical CSV file with some flights and the departure airport, departure time, and aircraft type, for instance. So here we can see the header, and then we can see 4 rows with values delimited by a comma. This is a nice, valid CSV file. The second example is a bit tricky because if we take a closer look, I intentionally added the line numbers here. If we take a closer look, it has 3 columns and how many records? Well, the first row starts with the ID 24, departure from, PRG, and then conditions. And here the value contains the new line. So the value starts here and it ends on line 6. So this is still the first record. So actually this CSV contains 3 records and a header, and it actually spans 8 rows. So this is a warning. even though some CSV files may seduce you to process them line by line, this is not a correct approach, because the values in the CSV files may contain new lines, and therefore number of records in a CSV file is not equal to the number of rows. And even though it might work for some CSV files, it will break the moment someone inserts a new line into a value. So yeah, this is a warning for you. If you are going to process CSV files, bear this in mind. And that's it. So otherwise, it's quite clean, clear, straightforward recommendation, let's say, RFC 4180. Now, let's take a look at how it works in a typical software for working with tabular data. And that typical software is Microsoft Excel. So if we have this CSV file that I've shown you and we try to load it into an Excel, it will not end up well, because Excel will try to open it with the wrong encoding, and it will not process the values containing line ends very well. Why is that? Well, especially in the Czech environment, this is caused by Excel expecting that the separator in CSV is not a comma, but a semicolon for some reason, which I will go into a bit later, which is, of course, incorrect. Fortunately, Excel, if you will decide to, for instance, work with Excel when working with tabular data, has a import facility from text or CSV, which you can use. And then when you point at your CSV file, you can set the import procedure to use UTF-8, to use comma as a delimiter, again called delimiter, but it is a separator. And then it actually imports almost correctly. Actually, it imports completely correctly. Just the new as to the new lines, Excel will show you the new lines only in the top view and not in the line view here. Okay, and what happens if you want to save CSV files? Well, you can actually, when saving files with Excel, you can choose a UTF-8 encoded and comma delimited CSV file when you are saving your file. However, when you do that, what you end up with when you open that file is a file encoded in UTF-8 with the byte order mark, which is invalid, and it will not use, at least in my case, in the Czech environment, it will not use the comma as a separator, but it will use the semicolon as a separator. So this is also not valid CSV. When I say not valid, especially regarding the separator, one might argue that it is quite natural to choose other separators, but that only decreases interoperability of data, right? So it doesn't, in my opinion, it does not make sense to create a comma separated value file and separate it by something else than a comma. It just doesn't make sense, and it will confuse many tools. However, since historically the situation with CSV files is like I described, that they are very different, most of the tools and libraries working with CSV data will allow you to set your own encoding and your own separator and so on. But not all of them, and those which take the standard version first will cause problems when you don't use a valid CSV. And now I promised I will explain a bit why Microsoft Excel actually uses a semicolon as a separator, and it has to do with the regional settings in your Windows operating system. So if you go there into the region settings and additional settings, you'll find a list separator definition there, and in the Czech environment it is by default set to a semicolon. And this is what Excel actually used in the past as a separator in a CSV file. So even though a CSV file again is named comma separated values, for some reason, Microsoft decided to use the list separator even there, which caused a lot of pain historically. Nowadays, I tried to change this, and it doesn't change the semicolon in the CSV file anymore. In older Excel versions, whatever you set here was outputted to the CSV file. Right. So there is a way of saving a proper CSV file in Microsoft Excel, but it requires you to save it using this Visual Basic for Applications macro, which is a bit overkill in my opinion. And it is just better to not use Microsoft Excel and use some other spreadsheet editors if you insist on using spreadsheet editors to work with CSV files. For instance, LibreOffice or OpenOffice, they allow you to import the CSV file correctly, and when they save the file, it is a valid CSV file. The same goes for Google Sheets. When you import a proper CSV file, it is imported correctly and it is also saved correctly. So Google Sheets is another tool you may use to also convert invalid CSV file into a valid CSV file. Now, Visual Studio Code has this Rainbow CSV extension or plugin, which does some nice things for you. If you work with CSV files, it will color the values in individual rows using different colors, and that's why it's called Rainbow. One downside here is that even this plugin, and it's the reason of how those plugins are implemented in Visual Studio Code, does not support the new lines in values in CSV files. So this is the one thing that will not work correctly, but otherwise it makes working with CSV files a bit nicer in Visual Studio Code. And it also allows you to query CSV files using a SQL-like language. So if you have a CSV file and you want to just do a quick query and you don't want to load it into a relational database, just to do that, this plugin may be something you will be interested in. Now let's take a look at some best practices when working with CSV files. The data types are not specified for CSV, and in CSV, if you are going strictly by the specification, everything is a string. However, since we are talking about data which probably will be published on the web, it is a good practice to use the same XMLSchema based data types as we use in RDF, in XML, and in JSON, and to use them also in CSV. So Boolean values, integers, decimal values, dates, times, date times, all those should be using the XMLSchema data type definitions. Also, the header is recommended to be present because it allows us to see at least a little bit what the data might be about, even though those column headers are typically very short. And it is the same thing as with, for instance, JSON and JSON keys. You have the labels there, but you shouldn't think that you know what the data is about just based on the texts in the column headers in this instance. Then one best practice is regarding null values. For instance, in XML or in JSON, there are explicit null values. And in relational databases, also null values are explicitly saved in the database. On the other hand, for instance, in RDF, there is nothing like a null value. So if a value is missing, the statement is simply not there. In CSV files, the practice is, again, quite diverse, but the proper practice is when a value is missing, then there should be nothing there. When there is null written, for instance, like in this case, then the value is the string null, which is a string like any other. and it is not a missing value. Now, one other best practice is regarding quantitative values. So in this case, weights, but also prices and so on. It is good, again, to split the numerical value from the unit or the currency. Like in this case, we have ID, departure, and we have a weight amount, for instance. I don't know, this may be a weight of an aircraft, for instance. And when you have those quantitative values, they also always have the numerical part and then the unit. So those are two different things, and they should be separated and not combined together as in the third example, or omitted whatsoever, because then the user needs to go into your data documentation to actually see what you meant by that number. And here we use the codes from the UN Act Common Codes of for units of measurement, which is the same standard that the good relations vocabulary used, and we already talked about that one. Right, this is similar. Basically, this best practice says do not use structured values. It violates the first normal form of relational databases, and also it makes the data harder to process, because you need to see how the list is or the list items are separated, and then you need to proprietarily parse the list. It is always better to do it some other way. For instance, by separating the list into multiple columns, or by duplicating the rows and only changing the values where the list was, and so on. So it is always solvable, but having a list inside a cell value is not a good practice. Now, there are some more best practices, and all these come from actual CSV files I found on the web, which do not do this properly. So CSV is meant to be machine readable. So it will not do any good to anyone if it contains, for instance, print formatting. So in your typical spreadsheet editor, it is quite common practice that you format your tables so that they can be printed out and read by people. But this is not the case for CSV files, because CSV files are not to be printed or read by people, they are to be processed by machines. And therefore, any formatting does more damage than good. For instance, this spreadsheet, when exported as a CSV file, looks like this. So basically it contains empty rows, some columns are empty, then in the data there are some missing values and so on. So this is not a good practice. When you want to create your CSV data in your spreadsheet editor, you may do that, but refrain from any formatting. And when your table looks like this, so basically it looks like a table in a relational database, that's actually a good sign, because when you export a CSV file like this, you will end up with a nice machine-readable CSV file. Also, what sometimes happens, again for the same reason, to be for the table to be read better by people. Sometimes people include sums into the table, and then, of course, when you want to process the CSV file, you need to create exceptions for the last 2 or 3 rows, because they contain some sums, which you as a machine can compute anyway. So yeah, this is also not good. And when talking about publishing CSV files, I need to mention that there is not just one style of publishing data in CSV. Some people prefer data set to be published in one big CSV file. Now, if or when you imagine a data set like the data catalog that we use or we used when we talked about conceptual modeling, but then we used the same data for our graph data and then for our hierarchical data. When you imagine that data like this with complex values and relations are to be flattened into a single relational table, it will not end up very well, because you will have lots and lots of redundancies. However, for some use cases like machine learning, this is actually preferred by someone, so it is one of the styles of publishing data in CSV. The other style is publishing multiple CSVs, the same way you would dump your relational database, which also contains typically multiple tables, interconnected, using foreign keys and so on. Now, when you publish CSV on the web, you should, in your HTTP content type header, specify the encoding if you don't use UTF-8, but if you use UTF-8, it won't hurt anyone if you mention it explicitly. And also the content type header contains the header part, which says whether the CSV contains a header or not. So these are two different content types for CSV files with and without headers. So this was CSV and how it can look like and what to look out for. And now let's talk a little bit about CSV and URLs. Remember that, for instance, in RDF, we have a URL or IRI for each RDF resource, for each entity. When publishing CSV files, you have a URL, for the whole table, right? So is it possible to actually point to a specific part of the table? Again, remember that when we talked about JSON, I talked about JSON pointers, where you can use a URI fragment to actually point inside your JSON file and point to a specific value. So let's have a look at how this could work for a CSV file. There is actually an RFC for this, RFC 7111, and it defines the fragments which allow us to specify parts of CSV tables that are published somewhere on the web. Examples are, for instance, here in the URI fragment, which means after the hash, there is a set of parameters. In this case, there is a row equal to 4, which should select the 4th row. Then we have column equal to 2, which again, the result of this is the column temperature selected. And there can also be a selection of a specific cell using coordinates, so row number and column number. So for instance, here we have cell 41, which corresponds to the 3rd of January 2011. Other examples of what is possible to do with the fragment identifiers are selections of multiple rows or even unlimited selections, like the second example is row 5 to the end of the table. The same goes for columns, and there is also a possibility to select an area of a table, which means that's the almost the last example, where we have the cell which starts at cell 4.1 and ends at cell 6.2. So this is a rectangle and contains a subset of the cells. There can also be a multi-selection, which means that the selected area is not continuous, is not connected. And in this case, we select row 3 and row 6. So those are semicolon separated. Now, what can go wrong with a technique like this? Well, you may specify a selection that's out of range, out of the table. So in that case, the selection is ignored. When you specify a range that extends beyond the table, the range is trimmed to what the table actually contains. It might happen that you somehow switch the order in which you select some rows. For instance, here it says that you select row 10 to 5, which is the inverse order than expected. So again, this is ignored. And when you have a multi-selection, when some of the selectors are invalid, they are just ignored, and they do not mean that the whole selection fails. So for instance, here, when we select the rows 1 to 2, that's valid, and then 5 to 4, which is invalid, the result is the selection of rows 1 to 2. Now, This RFC has a fallback mechanism because it uses the URI fragments, and when an implementation doesn't understand the URI fragments, it just throws the fragment away and it just gives you the whole CSV file. So it works even with implementations that do not implement this RFC. Before we get to the CSV on the web, there is one thing to think about. Since we already talked about conceptual modeling and real-world entities, there is a file, a code list of days of the week. So we have Monday, Tuesday, Wednesday here. And we have an IRI, then we have the label in Czech and the label in English. Now, the question here is, what is the difference between the two URLs at the bottom of this slide? The first one is the IRI of Tuesday, and the second one, when RFC 7111 is applied, actually selects the third row, which is again the row containing Tuesday. So what is the difference? Well, the answer is the first one actually identifies the day of the week, Tuesday, as a real-world entity. However, the second one identifies the third row of this particular table represented in that CSV file, which is a different real-world entity than a day of a week. The CSV on the web is the most recent standardization effort regarding CSV files. It is an actual web standard, and it is a set of 4 individual W3C recommendations from 2015, and it has the same use cases as any other schema language. So those are annotation, explaining what is in the data, validation, allowing users to determine whether a given file is valid or not against a schema. However, there is a third use case here, and that is transformation to different formats. And when you look at the list of the standards, the first one actually introduces a data model for tabular data. The second one establishes a vocabulary, which is an RDF vocabulary for describing what is in the data model. And then the last 2 recommendations deal with this transformation to different formats. The first one deals with transformation to JSON, and the second of those 2 deals with transformation of tabular data to RDF. But let's start with the data model. CSVW, which is the acronym for CSV on the web, looks at tabular data through this data model. On top, there is a table group, which can contain a group of tables. Then there are individual tables, and each table has rows and columns, and those rows and columns then contain cells. So it is quite a natural data model. The only thing that is not naturally based on CSV is the notion of table group. And each of those is annotated by a set of properties like names and for tables schemas. Let's have an example of an annotated tabular data model. So we'll have the 2 relational tables that I started this lecture with. The first one, airports and continents. The second one, airports and amount of snow in months. So these 2 together form a table group. Each of those tables is a table and has its URL, which is the URL of the actual CSV file containing the data. Then we have columns, and again columns have titles, and columns have also order. So column number 1 here is called airport in English, and rows have also numbers, but there are 2 kinds of numbering of rows in CSVW, and that is the number when not counting header, and then the source number, which is including the rows containing header. In CSVW, a header may have multiple rows, so that's why there are those two row numbers. Now a cell has a value and a data type, which comes from the schema. Right, so this is how the table is actually annotated using the data model. Let's now switch to describing the data model using the vocabulary, and we'll use the JSON-LD serialization. So from that we can see that it is actually an RDF, Resource Description Framework vocabulary. We already know JSON-LD, so this will be no surprise for us. The context of the JSON-LD is part of the W3C recommendation, and it is extended with the definition of a language of properties which do not have language specified, and a base for any relative IRIs used in the JSON-LD descriptors. So the notion of annotating those CSV files is that for each CSV file there will be an additional JSON-LD descriptor describing what is in those CSV files. Now we'll start from the top, from the table group. And in our example, the table group has two tables, but let's start line by line with the JSON-LD descriptor. So here we have the context link. Then we say that this JSON object represents a table group. Actually, if you took a look at the URL of the context, you would see that the string table group is an alias for an actual IRI representing the class table group. Then the ID defines the IRI of this particular table group, and what is required for a table group is the list of tables. So the tables key here has JSON array as a value, and the array has a list of objects which represent the individual tables. In this case, the only thing that is specified for the individual tables are the table URLs, which again contain the actual CSV files. Now let's move one level lower, and we'll talk about the individual tables. So here again, the table may be part of the table group, which was the first example, and in this example the table is actually standalone, which may also be the case for some tables that they are not part of any table group. Therefore they are annotated using their own JSON-LD descriptor, which is this case. So again, we have the link to the context. The type here is table in this case. There is ID of the table description, which is the IRI of the annotated table, which is different from the URL property, which contains the URL of the actual CSV file. So the first IRI is identifier of the annotated table, and the URL is the URL of the actual CSV file, two different identifiers. Then there is a title of the table, which uses Dublin Core, which we already know. There is a list of keywords. There is the modified date, and so on. Since we are using JSON-LD and therefore RDF, there may be other properties added as necessary or required. Now let's move on to the more interesting part, and that's the table schema. So the table description contains a table schema, which contains the columns key, which again contains definitions of the individual columns present in the table. And each column here has titles key, which contains the string which is used in the header in the CSV file. As we'll see later, there may be multiple values of this, but so far it is enough to say that the value of the titles key corresponds to the text which is in the actual CSV file as the column header. And then we have again a description, which is just an annotation, and then we describe or define the data type. So in this case, the airport is a string, And the required key here says whether or not it is required for a row to have a value in this particular column. So the airport column has the required set to true, which means that every row needs to have a value in the airport column. And the same goes for continent. In this case, the continent has also the language defined to be English. And again, it is required. Now we'll add multiple values to the titles key. Actually, and this is quite different from other schema languages, here for each column we may have multiple titles which can be used in the CSV file to denote this particular column. The titles key is actually a JSON-LD language map in this case, and it says that in English this column in the CSV file may be named airport or airfield, and in Czech it is letiště. This means that this particular schema can actually be used both with CSV files with English headers and with CSV files with Czech headers. And the schema stays the same. So yeah, this is a bit different. So in the schema we have a list of possible column names. And the same goes for the continent, where we have an English version or a Czech version. Now the data types. The data types are once again based on XMLSchema data types. In addition, CSV on the web defines aliases so that we do not have to use the prefixed or compact IRIs. So if the data type is any, then it's okay to use just the any word. The same goes for binary, datetime, and number. And they are aliased in the JSON-LD context to those IRIs that you can see. And there are also added data types which are not present in the XMLSchema list, and those are XML, HTML, and JSON, which means that you may have XML, HTML, or JSON as a data type of a cell of a CSV file. Now, data types may be also derived. So when we talked about XML and XMLSchema, I showed you how you can derive your own simple types based on other types. So the mechanism here is exactly the same. There is a base simple type. When the base is not specified, it defaults to string, and then you may specify your own data type using the usual techniques known from XMLSchema. When the data type is derived like that, the syntax for this derivation is a bit different, because before, when we talked about these derived data types, we were talking about XMLSchema, so the syntax was in XML. Here, the descriptor is a JSON-LD file, so the syntax of definition of your own data types can be seen in an example on the top right side of the slide. So here the base is integer, and it is an integer between 1 and 10. It's a new data type, and this data type is applied to a column in the CSV on the web table schema. Now another annotation that can be used with columns is name. Name is an identifier or part of an identifier of the column. So the columns here are not identified by the column titles used in the CSV files, because as we already know, there may be multiple ones, but they are identified by the names specified here in the descriptor. There is a restriction that the name is a US ASCII name, and that is because it is used later in URI references. So for this reason, the name can only contain US ASCII or %encoded characters, so that they can be used in URIs later. One more thing here can be seen, and that's the primary key definition. So in this table schema, we also say that the airport, and now notice that we reference the column using its name and not its title. The primary key is the airport column. Now, when we are talking about primary keys, we may as well be talking about foreign keys, which we know from the relational data model. And this is also something that is possible to represent in CSV on the web. So when we have a table group containing multiple tables, we may have foreign key references among those tables. So in this case, we have the snow table on the right, and we can see on the bottom that there is a foreign keys definition. It's an array, and there is one foreign key which references the airport column in table 2, and then it is said that this column references table 1 and its column airport. So this is a definition of a foreign key between two CSV files in one table group. It may also be defined using a reference to a schema rather than to a particular table. So in this case, we have a separate table schema published as a separate JSON file somewhere on the web. So on the left and on the right, there are standalone table schemas according to the CSV on the web. So those are JSON files just with the schemas, and the right schema references the left schema. And on the bottom, we have a table group definition with two tables. Table 1 uses the first schema, and table 2 uses the second schema. Now let's take a look at what support CSV on the web has for what I call nasty CSVs, which are non-standard CSVs that do not follow the RFCs for 180 and 7111. So when we talked about CSVs as such, I told you that proper CSV should follow what is written in the RFC 4180 and 7111. However, for historical reasons, there are CSVs on the web that simply do not follow these practices. The CSV on the web W3C recommendation contains support to describe what they call a dialect of CSV. Basically, it allows you to describe what is wrong with the CSV so that you can then interpret it better when you see it defined explicitly in the JSON-LD descriptor. There is also a best practice CSV dialect, and the example you can see on the right. So there is the UTF-8 encoding. There are two possible line terminators, CRLF and LF. The quote car is the double quote. The double quote is used twice when it is escaped. There are no rows to be skipped. What is new here is that CSV on the web supports comments. So here you can say that hash is a comment prefix. Then a proper CSV has a header, which has exactly one row. The delimiter is a column. There are no columns to be skipped. Blank rows are not skipped, and initial space is not skipped, and nothing is trimmed. Now, trimming is interesting because it allows us to remove spaces around values of cells. So maybe someone formatted a CSV file so it would look better when read by humans. So this should allow you to take care of those formatting white space characters around those values. And the comment prefix I just described. What's next? Well, in addition to the dialect, CSV on the web contains support for lists in table cells. So I already told you, do not use structured values or lists inside cells because that violates first normal form of relational databases, and it is hard for data users to know what to use as a separator and what the list actually means. Well, you can at least describe this using this JSON-LD descriptor, because you may for a given column, as you can see on the right, specify the separator of the list and whether or not the list is ordered. So in this case, and I do not recommend to do it like this, but I want to show you how you can describe it when you see it used. We have two airports, a list of airport codes in the airport column, and it is separated by a space. So this is what is also in the JSON-LD descriptor. Separator is a space and the list is not ordered. Next, there is support for null values. So again, I already told you when you do not have a value in a CSV file, you simply omit the value and that's it. However, if you find, for instance, a CSV where you have, let's say, the string null, or in this case, the string nada, and it actually means that there is no value, you can specify this again in the JSON-LD descriptor, saying that null is, in this case, nada. When there is a missing value, you may also specify that instead of a missing value, some specific string should be used as the value of that column. So in this case, and again, I don't recommend doing this because missing value is a missing value. Why hide it? But if you feel the need, you can do it by specifying the default value in the column description in the descriptor. There is support for various formatting of numbers. Again, you should use the XMLSchema data types if you want your data to be interoperable. But if you use something else or you find a CSV file using something else, you can specify the group character and the decimal character for the numbers, as you can see in this example. So here we have the group character, which is a space, separating the thousands from the lower order numbers, and a decimal character is a comma, which normally is invalid, but you can specify that this is how it is in your CSV file. The same goes for dates. You should use XMLSchema date, time, and date time. However, if you find a CSV file which doesn't follow those formats, you may also specify the format which it actually uses. As you can see on the right, we see that there is a data type which is based in the date data type. However, there is a special format, and that's a day, dot, month, dot, and four digits of the year. Actually, the CSV on the web recommendation is a bit demanding on the compliant implementations, because these are the date formats that the implementations must support. It could be easier if they just said, no, only XMLSchema data types are supported and that's it. No, there is a whole list of date and time formats, and also time zone formats, which need to be supported by every CSV on the web compliant implementation. So this makes things a bit harder on the interoperability, because it allows for this kind of behavior when publishing data. This is just an overview of the CSV on the web vocabulary. This is the same overview that we had, for instance, for the good relations vocabulary. So here we see what properties are usable where, and what is the data type. So this is just an overview of the vocabulary. Now let's say that we have the JSON-LD descriptor, and the question is, when we point to a CSV file on the web, how does one know, and by one I mean the implementation or the user, how does one know where to find the actual JSON-LD descriptor? Because it is a separate file published elsewhere. So the first option is that the user provides to the CSVW implementation the location of both the CSV file and the JSON-LD descriptor describing it. Then it's quite simple. The second option is that the link to the descriptor is provided on HTTP level when accessing the CSV file. So that's the example on the right, where you can see that a CSV file is served, and there is a link to the CSV on the web JSON-LD descriptor. So a client who is searching for such a descriptor can take this link and access it and get the JSON-LD descriptor. The third option is that there is a well-known list of IRIs, of descriptors, published on the web server serving the CSV file. So this again uses the well-known technique. So you take the URL of the CSV file on the web server, you strip the URL path, and you append /.wellknown/CSVM, and it should contain a list of JSON-LD descriptors describing CSV files published on this web server. The fourth option is that you take the URL of the CSV file and you append -metadata.json, and you get the JSON-LD descriptor. Then the fifth option is that you go to the CSV metadata.json relative URL. So this means that when talking about the last slash of the URL path, instead of the file name of the CSV file, there will be CSV metadata.json file. And the last option is that the metadata is somehow embedded in the CSV file. This is an example on the lower right, where we have a CSV file, and the first 4 lines are actually comments, which normally don't belong into a CSV file, but if it is a CSV on the web CSV file, then comments are supported, and those comments actually are formatted and they somehow contain some information from the schema encoded in the comments. But this is a non-standard way and implementation specific and so on, so I wouldn't recommend this one. Actually, what I use in practice is the option number 4, where we have the CSV file and we append the -metadata.json, and there is the JSON-LD descriptor. So we already talked about the annotation part and the validation part of the CSV on the web. And now let's talk a bit about the third use case for CSV on the web, and that's generating RDF from the tabular data described in this way. I already told you how to generate RDF from XML and from JSON in the other lectures, and today we are going to take a look at how to generate RDF from CSV files on the web. So let's have a CSV file on the left, and this recommendation actually defines a so-called default conversion. So with no additional description, if you take a CSV file and a CSVW compliant implementation, it should be able to generate an RDF representation of that table that looks like the one on the right. So here each row is a blank node, and the predicates, which are relative to the URL of the CSV file, those predicates are named after the names of the columns, and the values are string values containing the values from the CSV file. So like this, you have automatically an RDF representation of the CSV table. It is not a nice RDF representation because it doesn't use any vocabularies, it doesn't use data types and so on, but it is a start. So with no JSON-LD descriptor whatsoever, with no annotation, this is what you get when you run the automatic RDF conversion. Now, before I get to how you can customize this conversion so that it makes more sense, I'll take a technological detour here, and I'll quickly explain what RFC 6570 URI templates is all about. So this is basically a way how you can generate URIs based on a template, and the template looks like in the example. So here we have http example.com/ tilde, and then we have the curly braces and username, and this is what makes the URI a URI template, because username here is a variable and the curly braces username is an expression. And let's say that we'll have the username variable filled with Fred and then with Bob. When we do that, the URI template is expanded into a URI, and the URI will have Fred and Bob in the place where curly braces username was. So this is a very simple example. And actually, there are three variants of how the expression may look like. There is the simple string expression when basically what is in the variable gets in the result URI. The result, and I emphasize this, is a URI, not an IRI. So if you want the result to be seen as, for instance, a Unicode string, the implementation needs to decode the result of the URI template expansion. Then there is a reserved expansion, which means that there is a plus in the curly braces before the variable name, which works basically in the same way. However, there can be some encoded triplets, encoded characters in the variable value, and also there may be some reserved URI characters. And then there is the fragment expansion, which again works basically the same. However, the result gets prefixed with a hash, which means that you are making sure that whatever the expansion is, the value gets into the fragment part of the URI. And why I am talking about this? Well, the URI templates are used in CSV on the web for customizing the RDF that gets generated from CSV files. So in this example, we'll have the CSV which is on the top. It has just one line. We have already seen this CSV before. It's the days of the week CSV, and we have just Monday here. We'll have a table schema describing this CSV file, which is on the right. And it will contain, or we will use, three additional JSON keys here. About URL, which is the URI template for the RDF statement subject that should be used for this table row. The property URL, which is again a URI template, which will be used to generate a predicate in the resulting RDF triple, and then a value URL, which is again a URI template, and the result of the expansion will be a URI of the object in the resulting RDF triple. So basically for each column, an RDF triple can be generated. So here we'll reference in the about URL, using the URI template, we'll reference the value of this column, which already contains an IRI, as we can see. So that will be our subject. The property URL will be RDF type, so we'll want to say that this is a, and value URL is SCOS concept. So we'll want to say that this thing identified by this IRI is a SCOS concept, which means it's a code list item in this case. And the result can be seen on the bottom. So the result is a turtle file with the SCOS prefix, and it will contain that this IRI is a SCOS concept. Now, like this, each column could be only used to create one RDF statement, which might not be enough for some use cases. So if we need to generate more RDF statements, we'll need to add more columns. But since there are no additional columns in the actual CSV file, these columns will be added as virtual columns. So we will add one column at the bottom here, which will generate the triple that this item, or the day of the week, is SCOS in scheme, belongs to the IRI of the code list itself. And for that, we'll use the virtual column here. We'll say that this is virtual, which means it has no corresponding column in the actual CSV file, but it is used to generate RDF triples. And we'll end up with an RDF file like the one in the example. So like this, you may add some URIs and tweak a little bit the JSON-LD descriptor so that the resulting RDF makes more sense. And let's now go rather quickly through the rest of what is specified in the CSV on the web recommendation. So one thing we have not seen yet are custom transformations. So the JSON-LD descriptor may contain a transformations key, which is an array of individual transformations or templates. And each of those transformations basically says or links to a transformation script, names the transformation and specifies what is the format of the script. Preferably this is a media type. Then it allows us to specify the target format, which again preferably is a media type. For instance, that we generate text or RDF or something else. And if the target format doesn't have a media type, it can be any URL. And then there is the source key, which basically says whether before we start transforming the CSV file into the target format, whether there needs to be one of the standard specified transformations applied. And that's why this source attribute has only 3 possible values. Null means that the script works with the CSV file directly, and RDF means that the automatic RDF transformation should happen before the actual script is run. And the one recommendation that we didn't go through here is the one specifying how the table can be automatically transformed into a JSON file. So this allows us to say that the script works with this automatic JSON representation of the table. The rest of CSVW deals with bidirectional tables. So nowadays it is a focus of many standardization activities to actually support bidirectional tables for those which have the first column on the right rather than on the left. There is support for additional nodes that can be added to the table, and there is a hint that you could use the web annotations vocabulary, which is again an RDF vocabulary. There are special column names which start with the underscore, and those column names contain the % decoded representation of what is normally the value of the annotation without the underscore. But without the underscore, the annotation needs to be in US ASCII or % encoded. So with the underscore, you get the % decoded value, the Unicode value. And finally, you are able to specify that some of the columns actually form a title of a row. This is again for human readability and print friendliness of the description. Now, this is all I'm going to tell you about the CSV on the web and how it can be used to describe actual CSV files. Now, the remaining question is whether there are some implementations implementing this specification. The answer is there are a few, but there are not many, which is quite a shame because the CSV format is quite widespread on the web. It would be nice if more CSV files were described by the CSV on the web recommendation, the JSON-LD descriptor. However, there is one validator that partially supports CSV on the web. This is actually a student project, but it runs quite well. Then there is CSVlint.io. This one actually validates CSV without the support for CSV on the web. So it will tell you whether your CSV file has consistent number of columns, whether it uses Unicode encoding and so on, but it does not understand the CSV on the web standard. And those were online validators. There are also offline validators which support CSV on the web. The most complete support is in RDF tabular software, which is written in Ruby, but this one is actually working quite nicely with the CSV to RDF transformations and with the validation. And the CSV on the web recommendation is not the only way of how to describe CSV data. It is the standard one, standardized by the World Wide Web Consortium. However, there is at least one alternative approach, and this one is published by Open Knowledge International, which is a non-profit organization dealing with various things and also with data. And they propose something similar. They describe the CSV files using JSON, which is not JSON-LD. And the JSON allows you to do similar things as the standard CSV on the web. However, the JSON keys are named a bit differently and so on, but still you can see the example on the right. Instead of columns, the array is called fields. There is also primary key and foreign keys and so on. So it is very similar, it's just different. And in this context, you may come across what they call frictionless data, which is actually a way of packaging tabular data with the JSON descriptor and publishing this somewhere as a so-called tabular data package, which is nothing more than a zip file containing both the JSON and the CSV file, or they also have a support for representation of tables in JSON files. So there you have a support for actually describing a tabular data in a JSON file using a JSON descriptor. Nevertheless, this is not the standard way. The standard way is the CSV on the web W3C recommendation.